Hi friends, let us understand that in digital domain how to upsample a signal and downsample a signal. Or what do you mean by upsamplers and downsamplers? So today we are going to focus on upsampler and downsampler. Now, as the name indicates, upsampler means the samples will be increased, downsampler means it will decrease the number of samples. Upsampling, if we do, will it really affect the signal or will it make the signal more improvised? Or if I downsample the signal, will it degrade the quality of the signal? These are the very major questions that we need to first answer before actually understanding the system. Upsampling means you are increasing the sampling rate. That means I have certain system, I don't denote anything inside, let's say black box. I have a black box over here. Here I have a sampling rate at fx, and at the output I have fy. That is another sampling rate, and fy is greater than fx. By what relation and how, and that we will check it out. That is that I'm not keeping it right now. Just I say that this is my upsampler, so I'm considering my upsampler process, and in upsampling process I have just a system which should take an input of x of n, which is sampled at rate of f of x, and produce f of y, which is a sampled rate at f of y, and f of y should be greater than f of x. That is upsampling. How to achieve this? And if I upsample the signal, will it give me more rate of information? So it is actually a basic understanding that we should have. What we are doing is, we are not increasing the information. For example, on a CD with a rate of 44.1 kilohertz, the data has been already saved, and now I am giving the output at 192 kbps. Will I add up to the information? Have I increased the information on the disk? It is not so. We are just playing with the available data. What we are doing in upsampling, the exact process. We take the data, let's say I have the input sampled x of n as 1, 2, 3, 4, my favorite sequence, and I wanted to upsample the sequence. When I am going to upsample, or let us draw this, if I draw the sequence or the samples, this is my n and this is my x of n, correct? Now at n is equal to 0, I have 1, so I will draw it with another color so that it will be better to understand. It will be 1, okay. Then at n is equal to 1, it will be 2. This is 0, 1. At n is equal to 2, the value is 3. So at n is equal to 2. This is 1, this is 2, this is 3. And finally, at n is equal to 3, the value is 4. Okay. And what is the sampling rate? The sampling rate is the distance between these two samples, which is Tx. What is Tx? That we are not concerned about. We are just assuming that there is some Tx. Okay. Increasing the sampling rate means what I have to do is, I need to decrease the distance. What does it mean? Increasing the frequency. If I increase the distance, what will happen? Tx will increase. As Tx will increase, what is going to happen? Fx will come down, right? So at the output, I want to change the distance, right? That means I want some samples in between these two samples so that the distance Tx can be reduced. What should I bring in between these two samples? Okay, that is a major question. I can't have if I would have used an digital to analog conversion method, what would I have done is, I would have taken this signal, convert it back to analog, I will get an envelope, and that envelope I will resample it at different rate. That's not a problem. Here, because I am in digital domain, I am not going to change from digital to analog. I will be remaining in digital domain only. What I will do is, I will push some extra information from my side. Now that information is also very much now, because I don't know anything of how the data is coming from, because one discrete samples could relate to multiple analog signals. Let's not get into that, because it again comes to aliasing problem. So we will not get into aliasing now. Let us understand that if I got this discrete signal and I wanted to play with the data, I want to decrease the distance between the two samples, and I don't know what is happening between 0 to 1. I know what is happening at 0, what is happening at 1, and I want to decrease the data. Let's say I am increasing the sampling rate by a factor of, let's say, 2. I am increasing by a factor of 2. This is a method we denote. So my fx will be, my fy will be what? Twice that of fx. So I can write the relation as fx is equal to twice that of fx. Now you understood? So there is a relation. What is the system called as? Upsampler. What it will do? It will increase the sampling rate by factor of 2. What we do is, we push 2 minus 1 zeros in the data rate. How I will do it? See here. So what I will do is, I will draw again, and let us bring this samples as it is below. 1, 2, 3 actual, fx. This is my x of n, y of n, and this is my n. What I am doing is, I will be pushing 2 minus 1 0. What is the first sample? Let's say first sample n is equal to 0 is 1 as it is. Now I will, between 0 and 1, I will add one more 0. Then at 1 I will have this 2 sample. Between 1 and 2 I will add one more 0, and then there will be next sample which is at 3. Then I will add one more 0, and the last option will be of 4. Now we will see how I am jumping. I am jumping from 0. Now there is a new one over here. So it is 0, and then now I will write the red colored mark which shows the sampling rate of y. This is 0. Now this becomes my 1, the new one, because I have pushed a sample in between. The distance between these two samples now decreased. Now this is the sample rate. So this is the distance now of the sample rate. Then I have from here to here I will go, and it will be 2, then 3, then 4, then 5, then 6. So now we can see over here that we got a 0. Next sample is 0. So we are coming from 1 to 0, then we are going from 0 to 2, then we are going from 2 to 0, then 0 to 3, 3 to 0, 0 to 4. So now my sampling or n has been shifted from 0 to 3 to 0 to 6. That is, I have increased the sampling frequency. So before, the 4 was falling at an instant of 3, now it falls as an instant of 6. It is twice. We are doing this by integer factors only. This upsampler process can be done for any arbitrary integer value. Let's say I upsample a signal by I. total samples. Okay, I had an f of x and I have f of y. So what will be f of y? F of y will be equal to I times of f of x, because here it was 2 times of f of x. Similarly, here it will be I times of. Arrow shows that it is upsampling. Okay. Now, if I am doing upsampling by a factor of I and fy is equal to I times of fx, how many zeros will I add? There was 2, the upsampling rate was 2, so I added 1 0, that means 2 minus 1. So if I am now interpolate, or I am upsampling by a factor of I, then how many zeros will I insert? I will insert I minus 1 zeros. So we will insert I minus 1 zeros when we are going to do an upsampling process. Now it's not needed that you should increase or put zeros. That we will see later, that why it is not good that you should insert a zero. What will happen to the spectrum? This is all about, I am talking in terms of time domain, but there would be some effect on frequency domain also. You are increasing some data, you are changing the time itself, so the frequency domain will also get totally buffered because of what you are doing in the time domain. This is time domain characteristics I am showing, that we are reducing the timings. So we will do the frequency domain analysis just in a moment, but we will first finish looking at what would be the downsampler. I have taken the easier part first, that is the upsampler, because upsampler process is much more easier to analyze than the downsampler. Now let us understand what is the downsampler. Now for the downsampler, I again have a system. Okay, to this system I give an input and it produces an output. Input sampling rate is fx, output sampling rate is fy. In this case, fx will be greater than fy, or fy is less than fx. Just the complementary of the previous section. Okay, the symbol for this is downward arrow, and let us say I downsample again by a factor of 2. Okay, because I am downsampling now, I will not keep the sample rate. I will not take the sample rate from the previous example. Let us make a new example. Let us, for example, I have x of n as 1, 2, 3, 4, 5. I am downsampling by a factor of 2. Let's say 6, 0, 1, 2, 3, 4, 5, and let's take 6 samples. Okay, so now my n is going as 0, 1, 2, 3, 4, 5, 6. If we draw again, if we draw the sample rate, or if we draw the signal, this is my n, this is my x of n, and then we have at 0 we have 1, at 1 we have 2, then we have 3, then we have 4, then we have 5, and we have 6, and also we have lastly 7. Okay, I know the distance is not the same, but theoretically or in practice the distance is the same. When the system generates x of n, the distance will be the same. So this distance is my t of x, that is a sampling rate. Now I need to reduce the sampling rate, right? If I am reducing the sampling rate, what does it mean? The distance between the two samples to increase. So if I want the distance between the two samples to increase, I don't want it to be this much, I want it to be something else, or it to be widening up, right? So what we do is, we will drop the samples in between. So I will pick up this sample, I will drop the next sample, and I will pick up this sample. Okay, so the new signal that will appear to me is like this. this is my n, and let's say this is x new of n. Okay, I have 1, I will pick up 1 first. Okay, if I will draw the instances of n, so this instance will be 1, this instance will be 2, this instant will be 3, this instant will be 4, this will be 5, okay, and this instant will be 6, right. Just I have marked the images of the previous instances. Now I wanted to increase the sampling rate. What I will do is I will skip this, and now I will directly write, or I will put this sample. So now my third sample will be at the first position, or what I will do is I will skip this part and I will write here. Okay, so I got 3. Then I will skip this instant and I will write this. At this instance I have 5. Then I will skip this and I will put this instant. It is nothing but 7. Now what has happened is, for the output, when I see the output, I see this thing, that is from the sample 1 to sample, from this sample to this sample, the distance is now this one, which we call as Ty, which is new and which is greater, of course greater than Tx. So how we perform downsampling? Downsampling is performed by dropping the samples, and upsampling is performed by inserting number of zeros or number of samples. So for the new data, the instances will be like this. I will write with a black, or I will write with a blue, so that you will understand. The new instances will be like this: 0, next sample will be over here, which is 1, okay, then 2, and then 3, okay, and from 0 to 1 the sampling rate is Ty, which is of course greater than Tx, and frequency will be of course lesser than Ty. Understood? So this is how we do downsampling. So in general, if I show a downsampler with any infinite number of input coming, which will have a sampling rate of fx, okay, then my downsampler will be denoted as an arrow downwards with a d over it, which is indicating downsampling, and I will have an output which is nothing but fx by d. Okay, how much distance? This is my tx distance and this is my tx distance again. So tx and tx, 2 times of tx. So ty is twice of that of tx, or I can say fy is equal to fx by 2. Okay, so this is in generality we can write that if I have a downsampler of d of a factor d, then my fy, that is the output sampling rate, will be fx by d, where fx is the input sampling rate, and I will drop how many samples? I will drop d minus 1 samples. So to conclude the discussion, we come to a point that if I have an upsampler which is denoted by a letter, let's say I, and an arrow on it, then fx is the input sampling and fy is the output sampling, will be I times of fx. Fy will be I times of fx. In this we will be inserting the samples. Okay, and what type of samples we insert? We normally insert zeros between successive samples. Okay, then how many samples do we insert? We insert L, or say I minus 1 samples are inserted. So if I am saying an I or we say I level of upsampler, then how many samples will be inserted? I minus 1 samples will be inserted in increasing the sampling rate. Then we have the counterpart of this guy is downsampler. So over downsampler I have D, a letter D, and it is denoted, let's say fx is the input sampling rate, fy is the output sampling rate, then fy will be equal to fx by D. That is a relation. What I can conclude from here? Here we are not inserting, but what we are doing? We are dropping the samples. Okay. Then it will not have this line because we don't insert anything, so it will not give me we insert zeros of successive between the two. We are dropping how many samples we are dropping? We are dropping D minus 1 samples are dropped from successive samples, or we can say not from, we can say between successive samples. So between two successive samples I am going to drop D minus 1 samples, because in the previous example we took the D value as 2, so I dropped 1 sample in between. If D value was 3, then I would have dropped 2 samples. So this is what the upsampler and downsampler process is all about. Thank you.